2021, I realized that the video lecture for 4A had some more technical difficulties. So we're going to pick up here with slide 21. So in slide 21, we're looking at problem 5.1. We're trying to understand whether, just to determine the marginal product of capital and the marginal product of labor, given the production function, Q is equal to 100, K to the 0.6, L to the 0.4. And what we actually find out is we take our first derivative of our production function with respect to labor and then respect to capital. So when we do that, we end up finding that the total product with respect to labor is 17.41. And we find out that the marginal product with respect to capital is 104.46. And so all we had to do here was take the first derivative of our production function to find essentially our marginal product. And so just to make sure that we are understanding that in the slides, we have the wrong answer, and this is the wrong answer that is in the book as well. So this is 104.46. Okay, so now we're moving on a little bit to look more at the link between average product and marginal product. And so we already have our definition of average product, 5.7. Let's take the first derivative then with respect to labor, and let's set it equal to 0. And by doing so, we're trying to find the maximum point of average product. And so what we end up getting here is a simplified version for ourselves. So we're able to essentially, once we set it equal to 0, we're able to get rid of the L squared in the denominator. We know that the partial with L with respect to the partial of L is equal to 1, and that the partial of our total product with respect to labor divided by the partial of labor is just our marginal product. So we find out through some very basic algebra that the maximum of our average product will be equal to essentially our marginal product of labor. We find that it's equal to that. And so why do we understand that this is true? I think that's important, that we find this equality here. And so what we realize, the intuition is that when a marginal value is greater than an average value, then it must be true that the average value is rising. So the idea is, suppose your quiz average out of 10 was an 8. If your next quiz was a 9, your average would have to go up. And then with that same line of thinking, when a marginal value is less than the average value, then it must be that the average value is falling. And then lastly, when the marginal value is equal to the average value, then it must be that the average value is neither rising nor falling, but at a stationary value. So this is like having an average quiz score of 8, and then your next quiz is an 8. Your average stays the same. So what we next look at with our Cobb-Douglas production function here is a law of diminishing marginal product. And so we know what this definition means for us. It's as increasing amounts of variable inputs are combined with one or more fixed inputs, at some point the marginal product of the variable input will begin to decline. So we think about this little example that we have a farmer who begins cultivating 10 acres for tomatoes. That's our fixed input. And this farmer adds additional labor to work the crops, each additional farmer. And that's our variable input. So by adding additional labor inputs, production rises, and actually may rise a lot, and we would expect it to. But now imagine this farmer continues adding more and more additional farmers so that each additional farmer has only 1 square foot to work in. What we might actually see is 0 marginal product. If that's the case, if we actually get to our 0 marginal product, then we know that total product is maximized. So what is this going to look like for us? Well, our idea of a production function should look like this right now, and that is the first partial derivative of our production function should be positive. And this kind of equates to that as we add more variable inputs to the production process, output will increase. And now to make sure that the law of diminishing marginal product exists, we're going to take the second partial derivative of the production function, and we're going to make sure that it's negative. And so essentially what we've decided is with this is that our total product function will be increasing, but at a decreasing rate. So what will this look like in a general Cobb-Douglas? Well, we have a Cobb-Douglas production function, Q is equal to A times capital to the alpha, L to the beta. So let's take our first derivative with respect to labor. We know then that's the marginal product due to labor. And so what we get is beta times A times K to the alpha times L to the beta minus 1. And we know that'll be greater than 0. And it's greater than 0 because we've assumed that beta, A, and alpha are positive, and that they're less than 1, and K and L are also positive, then our partial derivative clearly has to be positive. So to determine the diminishing effect, we take the second partial derivative. So for us, we take the partial derivative and get beta times beta minus 1 times A to the K alpha, L to the B minus beta minus 2. And that has to be less than 0 given our previous assumptions, because we believe that beta is less than 1. And if that's the instance, then we have diminishing marginal effects. So how do we do this given a specific function? So we essentially have Q is equal to 25K to the 1/2, L to the 1/2. So what we could do to verify that diminishing marginal product exists in both capital and labor is let's first set capital to be constant, so that we're looking at the diminishing marginal product due to labor. And so we take our first derivative, and then we realize that it's greater than 0, because capital and labor will have to be 0. And then what we do is take our second derivative, and we can see when we take our second derivative that we get this negative sign here, which ensures we'll have a less than 0 diminishing marginal product because capital and labor, again, have to be positive. So when we do our diminishing marginal returns to capital, we'll set labor fixed. And so we take our first derivative, and actually our first derivative in this instance is identical, and we know it's greater than 0. When we take our second derivative with respect to labor, with respect to capital, we see again that it's negative because capital and labor will have to be positive. So we get overall a negative value there. And so we've thus, with this example, verified that diminishing marginal product exists. So next podcast, we'll be looking more in depth at the production function and a little bit more of the features that define this function for us.